Okay, good morning. So let us continue. So last time, if you remember, I started talking about the derivatives and tried to motivate you. The notion of derivative is important from two perspectives. One was the Leibniz problem, who was trying to find an equation for the tangent line to a given graph, and the other one was Newton's method to find the instantaneous velocity of a moving particle in one dimension. Yes? And then we learned that at least, considering those two examples, you realize that this kind of limit is important in mathematics. The limit was this. If you have a function and a given point in its domain, okay, we learned that this type of limit is important from these two perspectives. And whenever something becomes important in different areas, mathematicians actually try to investigate a little bit more on the problem and try to find its properties and delve more into it, okay? So this is why they give this type of limit a name, and that name is called the derivative, yes? So now let us start this definition formally. So, definition. So let f be a function with domain f, with domain df, df. The domain, do you remember? It means the set of all possible values that you can use for the input, yes? So let f be a function with domain df, and let a be a number in its domain. A belongs to its domain. The derivative of f at a, so some people write at x equals to a, but you can write the derivative of f at a is denoted by f prime of a, and it is defined as follows. We say that f prime of a is the limit of f of a plus h minus f of a divided by h goes to 0, provided that this limit exists. So you shouldn't be that much concerned about the last item, but in principle, a limit, it might be the case that you have a limit, but the limit does not exist. Yes? Yeah, if you have enough time, I will talk a little bit about that. So, the word that I want to use here, I will use it. I haven't seen in Swedish books, but this is the English term for that. So you need to say that if f prime a exists, then f is said to be differentiable. At a. So this word I will use. So if this limit exists, and if the derivative of a function at a given number exists, we say that the f is differentiable at that point. Okay, so let me give you an example. So just to remind you, so example. Let f of x be equals to x squared minus 2x plus 5. Determine if f is differentiable at, for example, x equals to -1, determine if f is differentiable at x equals to -1. If it is, determine f prime of -1. So in principle, you can answer both questions with the same starting point. You calculate this limit. If this limit does not exist, then you would say that it's not differentiable. If the limit exists, it is not only differentiable, but the value of the limit is the derivative. Yes? So in principle, we have to calculate this limit. So let me write the formula. I hope that you memorize that. Respecting the soul of Newton and Leibniz, you know. So we have this divided by h goes to 0. So here, this is the definition of my derivative. So instead of a, I have to put -1 in this problem. So f prime of -1 becomes the limit of f of -1 plus h minus f of -1 divided by h goes to 0. Yes? And then you have to calculate these things. So what can I do here? It depends which way you are more comfortable to do that. But f is an operator. You give an input to it. What is the role of f? It squares the input. It multiplies the input by 2, and then subtract it from this one and add 5 to it. Yes, adds 5 to it. So this will do the same thing for every input, including this input and that input. Yes. So for example, you can go to a scratch paper here and calculate f of -1. What is f of -1? I have to replace x with -1 everywhere, so it becomes -1 to the 2, -2 times -1 plus 5. And if you calculate 1 plus 2 plus 5 is 8. So f of -1 is 8. And we also have to calculate this one. So let me calculate it here in front. So this goes to 0. And then you shouldn't be lazy. You have to copy and paste this limit part until the very last step. So f of -1 plus h, it means that I have to replace this x with -1 plus h. So it becomes -1 plus h squared. -2, -1 plus h, plus 5, and then I have -8 at the end, yes? And then I'm supposed to simplify this. So this becomes the limit. I square this one, the first one squared, 2 times the first one times the second one is squared. I multiply -2 inside. Yes, and then divided by h goes to 0. And then you can see that this 1, 2, 5, -8 are cancelled. And then I have h squared minus 4h. So this becomes the limit of h squared minus 4h divided by h goes to 0. Yes? And then what happens here, if I want to simplify this, I factor h out. And then this one and that one are simplified, so this becomes the limit of h minus 4. H goes to 0, but then it becomes minus 4. So Is this function differentiable at -1? The answer is yes. And what is the derivative? It is -4. Yes? So let me write this here. So your answer is f is differentiable at x equals to -1 and its derivative at -1 turns out to be -4. Okay, so let me remind you, which is very important here. What is the geometric interpretation of this number -4? What is the meaning of that number 4 from geometrical point of view? That was the content of the previous recap, if you remember. The slope of, make it complete.
Tangent function.
No? Tangent line?
Tangent line.
Okay, no, more exactly. I want you to phrase it exactly. Yes?
The x-coordinate has to be -1.
Okay, just so what is -4 from the beginning? -4 is the slope
The slope of the tangent line at point, the x-coordinate of -1.
at the point on the graph of the function whose x-coordinate is -1. Yes? Is that right? So I don't know the graph here, so that's a parabola. So it means that if you go and do the graphing here, and if you go and find -1 on the x-axis and then find the corresponding point on the graph and draw the tangent line at that point, the slope would be -4. So that's important to remember. So let me write this remark now. That's extremely important and very simple, by the way. So remark. So the remark is this. So let me just draw a picture for you. Might be that is easier to remember. In general, if I have x and y, and then I have a function whose this is my function, and if this is a, okay, and then if I draw this tangent line here, the slope of the tangent line at this point, of course, the slope of this tangent line that you see in the picture is equal to f prime of a. So I don't need you to be able to say it in words, but this should be the picture in the back of your head, yes? So if you have a graph, if I calculate f prime at a number, it gives me the slope of the tangent line on the graph at that point whose x-coordinate is a. So remember that. I want you to remember this picture. That's extremely important, but of course simple. And there is another alternative formula for the derivative. It's also in the formula sheet, but I want to express it here for you. So one way, let me just describe it here. So you have f prime of a equals to limit of h goes to 0 of this combination, yes? F of a plus h minus f of a, h goes to 0. I want to rewrite this in a little bit different way. Okay, this is also sometimes you see in, I don't know, in other books might be you don't see this formula, your starting formula would be something else, but I just want you to have both of them. So here, let me call a plus h to be my new variable x. So let me call a plus h to be x. And I want to write this limit, which one of these letters, a or h, is variable in this limit? Which one of them is, of course, both of them I am using letters for them. But when this comes to this limit, I am sending h to 0. So I am fine-tuning h. So I'm changing h, but I have a as a fixed variable, yes? So a is fixed, h is changing. When h gets closer to 0, when h gets close to 0, what happens for this variable that I have defined? It gets close to what? When h goes to 0, h is negligible. X becomes approximately equal to a. So when h goes to 0, my new introduced variable goes to a, yes? And then what I want to write this, I would write this limit, instead of writing the limit in terms of h, I want to write the same limit in terms of x. Yes, so what will happen? H goes to 0 is equivalent to saying that x goes to a. So here I would write x goes to a. Instead of a plus h, I put x. Of course, a is a constant. I don't need to change anything here. But instead of h, I write x minus a if I move a to the other side. So this becomes another alternative formula, which is also very, very common in the context of derivatives. You also have it in the formula sheet, okay? So let me write this as a remark here for you, because I want to keep the example. So let me write the remark here. So you can say that the derivative of f at point A can be calculated equivalently using an alternative limit. So limit of the function itself minus f of a, the denominator is x minus a, but be careful. In the original formulation for the derivative, h always goes to 0, but in this new formulation, x goes to your a, depending which value of a you have chosen, yes? So x goes to a here. So I want you to also know at least about this formula. Any questions? Now I want to solve the same problem using this new method. And then you can compare which one is easier for you to choose if you want to solve the problem, yes? So here, let me clean this. Do you remember the answer was minus 4, yes? And you have the idea of how to calculate things here. So here, if I want to solve the problem using the new formulation, so I would write, let us write the formula here. So f prime a is equal to the limit of your function, whatever it is, minus f of a divided by x minus a. Be careful, x does not go to 0, it goes to a. And then what I'm supposed to do, I am supposed to calculate f prime at point minus 1. So this becomes the limit, your function, whatever it is, minus f of minus 1 divided by x minus minus 1, x goes to minus 1. Yes? Agree that this is the same formula that I'm using here. Then the point is that f of x, you don't need to simplify anything for f of x because f of x is directly given to you. So you don't need to replace it with something. So what we do, it becomes f of x, which is exactly the expression that you see on top, plus 5. Do you remember we calculated f of minus 1? It was 8, yes? So it becomes minus 8. And then x minus minus 1 is x plus 1. And then x goes to negative 1. And then you have to simplify and calculate this limit. So you see, the starting point was easier. Instead of calculating f of minus 1 plus h, we just plug in the function in, and then we are simplifying things. So then it becomes the limit of x squared minus 2x minus 3 divided by x plus 1. Of course, then you have to know a little bit of factorization. It depends which one is easier for you. I don't think the factorization of this is so hard. So do you remember how to do that? So you want to factorize this, and these are so simple numbers that you can guess. You ask yourself, I need two numbers whose sum is minus 2, if possible, of course, and its product is minus 3. So you open two pairs of brackets, put x here and x there. Now can you imagine two integers whose sum is minus 2 and the product is minus 3? What are those numbers? Minus 3 and positive 1, yes? So it's minus 3 and positive 1, yes? So if you don't believe, you can multiply. X times x is x squared. X times 1 is 1x. Minus 3x is minus 2x. And minus 3 times 1 is minus 3. So that is the factorization of that, yes? So this should be the sum. This should be the product. And then, of course, you immediately see that whatever this one is and that one are cancelled. And then you get the limit of x minus 3, x goes to negative 1, and the answer becomes minus 4 again. And then you can write the same thing here. So that is up to you. By the way, most of the time we want to avoid this, but sometimes, I don't know, it's still, they say that, okay, calculate f using the definition. So even if you know the formulas, how to differentiate, then you should, and then if they ask you to use the definition, you are not allowed to use the formulas, you have to use the definition. Then either you use this formula if you want to, or the original formula. That is up to you, yes? Any questions? Okay, but let me now try to see that this process is actually really boring. So let me just do some examples. I want you to learn this as well. So I will go and give you another example. So here you see that if I change this problem slightly, for example, I give you the same function, but instead of asking you about the derivative at minus 1, I can ask you what is the derivative at 1. Yes? Unfortunately, there is no shortcut. Even if I am changing it slightly, you have to redo it from beginning again. So instead of minus 1, you have to put 1 and send x to 1, and then you have to calculate it once more. And if I change my mind and I ask you, okay, calculate the derivative at 0, then you have to redo it again. Okay? So if you want to, if you are a mathematician, the best way is to calculate the derivative not at a particular number, for any number, and find the formula, and then using that formula you can answer immediately my questions regarding the derivative at different points. Is that understandable? So my point is that this is okay, if I'm only interested in the derivative at minus 1, that's okay. But if I want to have the derivative of this function at different points, it is not that efficient to calculate this several times. It is better to calculate it once for a particular, for a undefined number, for a undetermined number, so whatever it is, and then after that you have a formula, you can replace that number with any number that you want, and you can calculate it easily without going through this long process once more. Yes? For example, of course this is a little bit more lengthy, but you need to learn that as well. So I would say that, example, let f of x, I'm just copy and pasting the same problem here. Let this determine f prime not at a number, at any point x. So I want to determine f prime of x. Yes? So it means that, let me calculate this. So I want to calculate f prime of x. Do you remember what was the formula for f prime of a? This time, instead of a, I have to put x. And then this becomes the limit f of x plus h minus f of x divided by h goes to 0. In this course, this formula is very important for us. Okay? Whenever we want to discover the formula for the derivative of a function that we don't know, we have to use this. Okay? So is the formula clear? So I have just replaced a with x. A was a specific number, but here x is any typical number that you want to. But the rest is simple. So what we have to do, the rest is more or less the same thing as before. So f of x plus h, it means that go to your function, replace every x with x plus h. This becomes x plus h squared minus 2x plus h, and then plus 5, and then minus f of x. So it becomes minus x squared minus 2x plus 5, and then divided by h. It is lengthy, I agree, but you shouldn't be confused. There are two variables apparently in this problem. X is also a variable, but not for this limit. For this limit, h is the variable. X is supposed to be a constant number. So I'm not touching the value for x, whatever it is. I'm just sending h to 0, yes? So then I have to simplify this a little bit longer expression. So this becomes the limit. If I raise it to power 2, it becomes x squared plus 2hx plus h squared minus 2x minus 2h plus 5, and then I multiply this negative sign in, and then divided by h goes to 0, yes? And then what happens? Let us simplify. This x squared and that one are gone. Minus 2x, positive 2x, positive 5, negative 5. So let me write here. So this becomes the limit. What is left for me? 2hx plus h squared minus 2h, yes? 2hx plus h squared minus 2h divided by h goes to 0. Okay, what is the next step? Clear, yes? I can factor an h out. It becomes 2x plus h minus 2 divided by h goes to 0. And this h and h cancel, and then I have the limit of 2x minus plus h minus 2, but h goes to 0. So I'm not allowed to touch x, whatever it is, it remains x. So what is the answer? Is 2x minus 2. Yes? And that is exactly because you have already passed this course Math 3C, so you know the derivative of this is 2x minus 2. Yes? That is the reason behind it. Okay, so what I get is this. Okay, so what should I do here now? I would write f prime of x is equal to 2x minus 2. This is the general formula for the derivative of this function. And then you can answer whatever you want to using this. But I want you to understand x is an operator. So you see x, you send it to f as a machine or whatever. It gives you what? X squared minus 2x plus 5. It's extremely important to have this picture in mind for a function. A function is a machine, is something which operates. You send an input in, you get an output. Yes, that is the role of your function. Yes. So what is the role of this function? It squares, multiplies by 2, and then make this construction. Yes, that would be the output for x. Exactly, I want you to think in this way for the derivative. That is why derivative is something, it means in English that something you derive from something else. So this derivative is also a function. But what is the role of this function? You send in x, but what do you get as the output? You get 2x minus 2. So it means that this is a function again. Yes, f prime is again a function which is derived from the previous function using some process. Yes? The process of going from this to that, from here to here, is called differentiation. Okay, so the process of going and finding the derivative of a function from the function itself is called differentiation. Yes, in English. So this is a very important picture to have in mind. So you have a function, which is an operator that takes an input from you, gives you this output. The derivative of this function is also a function, but it takes x. For this function, it gives you this back, 2x minus 2. Is that understandable? So now, if I ask you, what is f prime of minus 1? If I ask you, what is f prime of minus 1? What is the answer? It means that you need to go to the f prime operator, f prime machine. Your input this time is minus 1. So you are sending minus 1 into this machine. So what will be the output? The output will be 2 times your input, minus 2, which is exactly minus 4. Yes? Is that clear? So it's very extremely important from now on. Please don't forget this. If you want to calculate the derivative at a number, so you have to find the general formula for the derivative first and then replace x with minus 1 or whatever you want to. Yes? Be careful about that. So in principle, when I say f prime of a, it means that you have to calculate f prime first and then apply it on the number as your input. So be careful about these points. Okay. So here, if I ask you, if I change my mind and I ask you what is f prime of 0, even though I suffered a little bit more to calculate this limit, but the price will be paid back to me here. Yes, I will be, I can calculate these things very easily now. Because if I ask you what is f prime of 0, I really don't need to start this boring calculation from scratch again. What I need to do, I need to replace x with 0. And then the answer becomes minus 2. Yes? So you can continue this process. Okay. So whenever we want to find the derivative of a function, there is, for the time being, forget about what you have learned in Math 3C. There is only one way for us yet, and that is this one. And one way for us so far, and that is using this word. I want to give you some practice for this, for 2 examples. I want you to see them, but you don't need to be worried about these methods. But I just want you to appreciate that if you want to do it just in this naive way, it would be very horrible sometimes. And by the way, sometimes impossible. Okay, so that is the point we want to consider here. Because calculating limits in general are not easy. Yes? So just let me give you another example. I will give you 2 more examples, okay? Okay, so let me clean everything and then write this formula on top in front of our eyes and then use the 2 examples. Okay, so example. Let me write it in this way. Determine the derivative of each function of the given function. But of course, if I want to give you this question in the exam, if I mean to do it in this way, I have to write determine the derivative of the given function using the definition of the derivative. So be careful about that, yes? And don't get confused. If I don't emphasize on using definition, don't use the definition because it would be horrible, yes? So, number one, let me give you an example. I want to make it, so let me make this square root of x. In principle, from what you have learned in Math 3C, you should be able to do it, yes, square root of x. And the second one, I make it a little bit harder because that would be the last thing. So let me change the name of my function to g this time, and then let me write it as x plus 1 divided by x minus 1. This you don't know how to do it in Math 3C. We will learn it this year, and that is called the quotient rule. But still, if you don't know the quotient rule, you can still use the derivative definition and find this. So this one, in principle, if you have done your homework fine in Math 3C, it is doable for you right now. But this one, it's not doable for you right now because you don't have the formula. Okay, so let us just do these things together, okay? There is a trick I want you to teach you. It might be forgotten. So the first thing that I write, by the way, let me write the formula here. F prime of x is the limit of f of x plus h minus f of x divided by h goes to 0, yes? Okay, so let me use it here. Number one, f prime of x is equal to the limit, and then I have h, the denominator h goes to 0, but f of x plus h. So what should I write for f of x plus h? What should I write? Just tell me because I want to make sure that you know it. If you know it, please save my breath. Yes? What is f of x plus h? The square root of
X plus 8.
x, yes, exactly. Minus f of x, which is this one. And then I want to calculate this limit. Yes? This is not that hard, so you need to know at least these simple tricks for calculating the limits. First of all, you see that I am not allowed to put h equals to 0 right now because the denominator vanishes and the division by 0 is not allowed. Yes? So what I have to do, there is a trick for that. Do you remember, any of you who had some lessons with me? Do you know how to simplify that? Yes? By the conjugate pattern. So this is the trick you want to learn right now, okay? So what I do, I will do it like this. I will copy and paste the whole expression, but what I do, I rescale it by the conjugate of this. By conjugate, I mean an expression so that after being multiplied by that, it makes a conjugate pattern. So first of all, I want you to appreciate that what I have written here is valid. This equality holds, yes? Because what I have done, I have multiplied this whole expression by 1, yes? There is no difference between this and that, so this fraction is actually a fancy way of writing 1. But why is that useful? Because when I multiply this by that, then I will make a square pattern. So you will see, you need to be patient to see why this method works. So if I multiply this by that, that is a conjugate pattern. So it becomes the first one to the 2. Let me this time write all the details. The first one to the 2 minus the second one to the 2. And then the denominator, don't multiply it, just juxtapose them. Yes, just write them next to each other. So plus square root of x. H goes to 0. And then let us simplify. So the numerator becomes x plus h, because this power of 2 will kill this square root. And then this the same, it becomes minus x. And then let me copy and paste the denominator. And then what happens? This x and that x are cancelled. H goes to 0, and now the good point is that h is also cancelled. And that was my problem, yes? Because I didn't want to have h in the denominator like that. So then the numerator is 1, the denominator is x plus h plus square root of x, h goes to 0. And then what happens? When I put h equal to 0, it becomes 1 over square root of x plus another square root of x. Yes? And then it becomes 1 over 2 square root of x. So that is the formula. This formula is not in the formula sheet, but let us just tell it right now, because in the future, of course, you can find it much easier, not with this method, but I want you to memorize that, okay? It's up to you, but I really want you to, this is a famous function, I want you to memorize the derivative. Any questions? Now let me draw your attention to some points. Do you remember I told you that if the limit exists or whatever, but we didn't pay attention that much to it? Let us consider this function. For this function, assume that I have given you this function. This is not part of the solution, so let me change my color here. So if I give you this, do you think I am even allowed to ask you about the derivative at -1? Can I give you this function and I ask you what is the derivative of function at -1? Yes or no?
You can ask about it, but it will be not a
No, I am not allowed to even ask. The reason is that I told you that the derivative of f prime of a makes sense if a belongs to the domain in the first place. If a does not belong to the domain, it is not even a proper question to ask. Okay, so you cannot say that like complex numbers, it would be a complex number. No. I am not allowed to ask the derivative of this function at -1 because -1 is already outside the domain of this function. What is the domain of this function? The domain of this function is the set of all positive, non-negative real numbers. This is the domain of this function. But this number does not belong to the domain. If it doesn't belong to the domain, I am not allowed to even ask about this. Yes or no? Be careful about that. But am I allowed to ask this? I am allowed to ask this because 0 is in the domain. But what the answer is, so let me just draw the diagram for you. The f function, you send x in, what you get out is a square root of x. For the derivative, what you send in is x, what you get out is this one. Yes? So you see, am I allowed to send x, am I allowed to send 0 here? Yes, the answer will be 0. But exactly, am I allowed to send 0 here? The answer will be not defined. So you see that even though 0 is in the domain, but it is not differentiable at 0. Yes? So you will say that this is not defined. The best way is to say that f is not differentiable, yes? Differentiable at, this you have to write it complete. F is not differentiable at x equals to 0. Yes? So be careful. This was actually an ill-defined question. I'm not allowed to ask about f prime of -1 because -1 is already out of the domain. But 0 is in the domain, but the process is so in a way that, as this calculation shows, that the derivative becomes that which is unfortunately meaningless when I put x equals to 0. So this means that f is not differentiable at x equals to 0. Is that clear? Okay. This I want you to know from this function. So this is what I want to say. You're not allowed to say f is not differentiable at -1. Because -1 is already excluded from its domain. Differentiability makes sense if you are talking about the points in the domain. Be careful about that. Yes? Clear or not? Okay, so let me now clean this. And I really want you to memorize this formula. It's extremely important for our course. Otherwise, you will be in trouble. You have to start calculating this over and over and over from scratch. Okay? Not using this method, of course, an easier way, but I really recommend you to try to memorize. Okay, now let us go have some fun with this function. So that would be a little bit hard, and I want to tell you that according to Math 3C lesson, you were able to calculate that, but according to what you learned so far in Math 3C lesson, you are not able to do this. Okay? Unless you use the method that I want to use right now, not using differentiation rules. Okay? So number 2. So what is the derivative? G of x, G prime of x is equal to the limit of, instead of f, I have g. G of x plus h means I go to my function, replace every given x with x plus h, yes? So then it becomes x plus h plus 1 divided by x plus h minus 1. And then minus f of x. And then divided by h goes to 0. So the goal is to calculate this limit. And of course, as usual, you have to start simplifying the expression here. So I don't know, what is your suggestion to simplify that? So let us do it a little bit fast, yes? I want to get rid of these partial fractions. So you see I have a big fraction here and partial fractions here and there. I want to get rid of all these partial fractions, so I have to rescale the fraction. I rescale the fraction by this factor, yes? X minus 1 times x plus h minus 1, agree? So it means that I multiply the whole numerator by that expression, and then of course I have to multiply the denominator by the same expression. So first of all, let me just do the denominator, which is easier. So I take h and I will multiply it by that combination, yes? X minus 1, x plus h minus 1. H goes to 0. Okay, can you tell me what should I do in the numerator? I want to multiply the whole fraction here by that expression, but this part then being multiplied here, this part and that part will be simplified. What is left for me is x minus 1 that I have to multiply in the numerator, yes? So then what happens, it becomes x minus 1, x plus h plus 1, and then I have a negative sign in between, the same process for this fraction. Meaning that I multiply this by that, this one and that one are cancelled, what is left is this one, I multiply it here. Yes? Is that understandable? And then the rest of it is, we have to be a little bit patient to expand this, and simplify. Yes? So what can I do? Let us just do it quickly. So this becomes the limit. The denominator, just copy and paste it here. And h goes to 0. And then I multiply this. It becomes x squared plus xh plus x minus h minus 1. I multiply this, but an extra minus sign I have to apply for all the terms. Yes? x is x squared, but negative x squared. X times h positive, but it turns out to be negative. This one becomes negative, so it becomes positive. Minus x minus h plus 1. Yes? So I am doing simple algebra, yes? And then let me see that this x squared and this x squared are gone. This minus 1, for example, and that positive 1 are gone. xh minus xh. So is there something left? Yes. Minus h from here, minus h from there, so it's minus 2h. Yes? So it becomes the limit of minus 2h divided by h, x minus 1, x plus h minus 1, h goes to 0. Okay? But let us just do this last part without rewriting it. Yes, this h now in the numerator and this h in the denominator can be simplified. Yes? That is it. And then I send h to 0. So when I send h to 0, it means that I keep x fixed. Yeah, I don't need to write this at the last. So it becomes minus 2. If I send h to 0, this will not be affected. But this becomes 0, it becomes x minus 1. And then what you get? You get minus 2, x minus 1 to power 2. This is not something that I want you to memorize, but we were able to calculate that. So we learned that the derivative of this function is equal to minus 2 divided by x minus 1 squared. It's a little bit odd combination, yes? But this is how it is. Any questions? Okay, let me ask you one question. Is it sensible, is it meaningful question to ask this?
No.
Is it a meaningful question to ask this? No. Why? Because 1 is not in the domain of the function in the first place. So you are not even allowed to say what is g prime of 1, because 1 is excluded from the domain of the original function. Yes? So what does it mean? It means that, okay, so I am not allowed to ask g prime of 1. But am I allowed to ask g prime of any other numbers? The answer is yes. But do you think the function is differentiable on its domain? What do I mean by this sentence? It means that whatever number you choose from its domain, do you think g prime of that number exists? Yes or no? So the only number that I'm not allowed to choose is 1.
Yeah.
And the only problem with the derivative is also 1. So if I don't choose 1, which I am not allowed in the first place, I don't have any problems with the derivative. So it means that the function is differentiable not everywhere, it's differentiable everywhere on its own domain. Yes? But that function, do you remember, square root of x was not like that. It was not differentiable on every point, at every point in its domain, because 0 is the domain, is in the domain, but it is not differentiable. Okay. These two examples, I want, first of all, you learn about these tricks, and then the second is that you see that this is really boring.
Yes.
Yes? And then, if I want, by the way, this is the way that Newton did it. So they didn't know about those formulas and things like that, so if they wanted to calculate things, they calculated it that way. Okay? But the point is that this process is not only boring, but not efficient at all, unless, okay, for example, Newton, that was not a big problem for Newton, because Newton was solving physics problem, and the functions he was considering was coming from physics, and they were limited. For example, I don't know, for example, for the gravitational law, so you had this formula, gm divided by r squared, so the function he was caring probably very much is k, a constant, divided by x squared, you know. The variable was this one, because this is the distance from two objects, okay? And if you are changing that, that's your variable. So Newton was caring about probably at most this function. So it was not that problem for Newton to try to solve it once using this trick. Yes? But in mathematics, but for Leibniz that was a big problem. Because for Leibniz, you have to change the function from one function to completely different function, and then you want to still be able to calculate the derivative. So then it means that from mathematical point of view, it's not probably that efficient, but of course later physics actually advanced much more, for example in electrodynamics and whatever is related to electricity. If you want to do it in naive way, probably you will not be able to finish it at all. Okay, so then it means that later, even in physics, we have to get rid of this bad, long process and boring process. Okay, now I want to ask you questions. Okay, now you are a mathematician, and you want to continue, you want to push the borders front, yes, to the front. So what do? So you realize that, first of all, learning derivative is inevitable. You have to learn it. And then on the other side, you don't like it because it's so boring. And then you want to make it efficient. Assume that you are living in the 19th century or at 18th century and you want to do something. What is your starting point? Let me make it more clear. So you see that from function to function, the process is quite different. So I have to redo it. On the other hand, naturally we are lazy beings, yes? We don't want to repeat something boring over and over again. So what we should do, in principle, if you were a mathematician, yes?
Figure out a way to find out the derivative of every function.
Okay, so that is actually the goal. But, is it possible? How many functions are there? Infinitely many. So, and in principle, even if you are superhuman, you will not be able to finalize infinitely many functions, yes? So then it means that you need to find a wiser way to do that. Exactly, I'm just giving you, that's the natural feeling comes in. So you want to find a way to find the derivative of all functions, but the first step towards that is...
You maybe have to categorize the different functions.
Yes, that is the most important trick that we want to use. We want to categorize the functions that appear probably in mathematics. Yes, so it means that I want to start with some famous functions and do the calculations once for them and tabulate them in a table or memorize them and use them over and over again if those functions appear in my context. Is that clear? Okay? Yes, this is clear. But how should I categorize them? So it means that I should think what type of functions appear in mathematics. The simplest possible function ever is which function?
X squared.
No, much simpler. Yes?
X is a constant.
A constant. A constant is a boring function, but that's a function. Yes? So, it means that what we want to do is to categorize our functions. So, we know that the simplest possible function in mathematics is the constant function, not a constant function, because we have different constant functions, yes? For example, f of x is 2. That's a constant function. So what is the role of this constant function? It's actually like dictators, yes? So whatever you send in, they don't care. Yes, they send out 2. So it doesn't matter what you put in. They say that no, I give you 2. Okay? But we have more dictators, yes? We can have g, yes? And then you send g, and then that will give you minus the square root of 3. That's also a constant function. Yes? So if I want to write it in more familiar language, even though this might be a very good way of imagining a function, always have these diagrams in your head when you think about a function. Yes? So then if gx is minus the square root of 3. Yes? So this guy is even worse than that guy because it gives you negative values. Yes? Yes. But anyway, these are constant functions. So in principle, if I want to talk about a constant function, I would write f of x equals to c. C is a constant. Now we want to calculate f prime of x for this function. Yes? Okay. So let me try to have my table from Math 3C. I will not be able to go through all derivations for those, but you will understand what is the core, what we want to do. So here we together learn that we have to categorize our functions into groups that appear a lot in mathematics. So I would write f, and I will write f prime here. The first category is the category of constant functions. Yes? By the way, what is the graph of a constant function? What is the graph of any constant function? Is a horizontal line. Yes? Is a horizontal line that passes exactly through that point on the y-axis. Yes? So and then what is the slope? By the way, that's also good to know. What is the slope of the tangent line at any point? This is a little bit extreme, but well defined. Yes? For example, f of x equals to 2 is this line. If I ask you, can you give me the slope of the line tangent to it? It's a little bit crazy, but that's also you need to know. If I ask you, what is the tangent line to this graph at this point? What is that? Yeah, you need to remember, by definition, it's the same line itself. So the line itself is tangent to itself at every point. And I told you that. What is the slope?
Zero.
The slope is 0, and the derivative is equal to the slope.
Yes.
So the derivative is 0.
Yes.
Yes, but let us do it formally. If I want to prove it rigorously, what I'm supposed to do, I have to write the formula for this function. For this function. It becomes the limit of f of x plus h minus f of x divided by h when h goes to 0. But I told you that h is h goes to 0, f of x is capital C. But can you tell me what is f of x plus h in this case? It's C again, yes, because I told you that they don't care. Constant functions don't care about the input. They always give you the same output. So f of x plus h is again C. And C minus C is 0, 0 over h is 0, so the answer is 0. So the first thing you need to remember is that the derivative of a constant function is 0. Okay? So for example, if I give you f of x equals to square root of 3, what is the derivative? 0. If I give you f of x equals to sine of pi over 3, what is the derivative? What is the derivative? 0, because sine of pi over 3 is a constant. You don't care how this constant is written. F of x is equal to pi, I don't know, to the power of pi. What is the derivative? Pi is the constant pi number. What is the derivative? 0 again. Yes? So it doesn't matter how the constant is written. For example, what is the derivative of this one? Logarithm of pi plus sine of square root of 3. What is the derivative? What is the derivative? It's 0. Because it doesn't matter how you have written your constant. If that's a constant, that is the derivative is 0. So the derivative here is again 0. Yes, so be careful. The constant is, the derivative of a constant is 0. Okay, now after the constant functions, what is the next common function in mathematics? Make probably functions like this. X to some power, yes?
Yeah.
X to some power, either, of course, if this power, so let me give you the formula. You had it in Math 3C. So if I write it as x to the a, its derivative is what? A goes down, x to the power of a minus 1. But here, by the way, let me write it C. Let me use C for constants. Not get confused, yes?
Oh.
So x to the power of a constant, it is extremely important. So if I ask you to differentiate this function, you are not allowed to use this rule because x is not a constant. X to the power of c, the derivative is c goes down, x to the power of c minus 1. This is extremely hard to prove in general situation. It is very easy to prove, and I want you to do it as an exercise. For example, you should be able to do it for f of x equals to x squared. You should be able to do it for x to the power of 3. Yes? This is possible for you. If you do this using this long process method, you will get at the end 2x for the derivative. And for this one, you will get 3x squared. Yes? But it is not easy at all if I give you what happens for x to the power of 1/2. The good news is that even this one follows the same pattern,
Yes,
but extremely harder to prove. Not this one, that's not extremely hard. We did it, do you remember? But if I change it to 1/3, or if I change it to 1 over n, then it becomes harder. Not extremely hard, harder. And of course, I can also have this situation, then it becomes a little bit more harder. So what happens if I have a square root of 2? But the good news is that whatever this constant here is, it follows the same pattern. Yes, is that clear? What I want you to see, if you're really interested, as we did it here, you can do it for this one. This becomes harder. You need to learn something in Math 5 to be able to do that. But this one is much harder because what the meaning of this one is not that clear probably for you. But the good news is that all of these exponents follow one single rule, and that is this rule. Yes? Is that understandable? Okay. Now, we can, by the way, solve a lot of problems using that formula. What are the special cases? Let me change my color and write the special cases there, yes? So, one special case, I want you to memorize it separately. If C is 1, what happens? If C is 1, then 1 goes down. 1 minus 1 is 0. X to the power 0 is 1, so it becomes just 1. Yes? So the derivative of x is what? 1. Is that right? By the way, that's not a very good way of writing. It means that if f of x is x, then its derivative is 1. I have summarized it in that way. But I want you to know that this is a special case of this general case. And then I told you that if you have a square root of x, let me write it here. The square root of x, what is the answer? Is 1 over 2 square root of x. Why is that? Let us do that using this formula again. So if I ask you to calculate the derivative of this function, the first thing that you have to do, you have to rewrite this in this form.
Yes.
And then you can use the same trick. 1 over 2 goes down, x to the power of 1 over 2 minus 1. And then you simplify. So it becomes 1 over 2, x to the power of minus a half. You can stop here, but you can also do that trick to make it simpler, yes? So what I do, I write 1 over 2, I take it to the denominator and make this one positive. And then what happens, it becomes 1 over 2 square root of x again. And that's exactly the formula we got. I really want you to remember this, because this will happen a lot in this course. It's better, even though it is not separately in the formula sheet, so they always think that you will be able to find it using this. Somehow it is good, but after learning it becomes boring, so let us memorize it. That's up to you. Any other special case that is interested for us? Let me say, what do you think if I want to calculate the derivative of this? Is it possible? Using that formula.
It should be, because it's just x.
Minus 1, yes. So it becomes x to the power of minus 1 prime. And then minus 1 goes down. X to the power of minus 1, 1, minus 1. So then what happens? It becomes minus 1, x to the power of minus 2. And then I prefer to write with positive exponent, so it becomes that. That's also a famous function, but let me write it here for you. You don't need to memorize it separately, you can immediately do that, but it is good to know that this is also the case. So these things that I have written in red are special important cases of this formula. Yes? Okay. Let me give you another exercise. Can you calculate the derivative of this function? F of x equals to x to the power of 3, the fourth root of x to the power of 5. So we want to calculate the derivative of this function. Yes? So still that formula is enough for us. But we cannot start using that. I have seen some mistakes students do. They differentiate this part and this part separately. This is not possible. We will learn this a while later, that this is called the product rule. If you know the product rule, then you will be able to do something like that in the future, but right now you have to use only that formula. So you have to change the form of this function in a form that you can see it in your table. So what should I do here? F of x is equal to x to the power of 3 is x to the power of 3. What can I write instead of this guy? I hope that you remember this. This I know. This is in the formula sheet. But this one is not. So this is not hard to remember. So this becomes the same thing to the power of m. So it becomes m over n. So please write them somewhere. You will be able to, you have to use them. So be careful. N goes to the denominator, m goes to the numerator. So here I will do the same thing. This becomes x to the power of 5 over 4. And then, still it is not good enough for me. I need one power of x. There are two powers. So I have to combine them. I write x and I will add them, yes? And then what happens? It becomes x to the power of 17 over 4. And now it's enough for me to start differentiation, yes? So 17 over 4 goes down, and x to the power of 17 over 4 minus 1. So it becomes 17 over 4, x to the power of 13 over 4. Yes? That is enough for me, but if you want to simplify things, you can continue and write it as the fourth root of x to the power of 13. But usually, it's possible, take as many as things you can get out from this square root sign, yes? So it becomes this. What can I do here? I can write it as x to the power of 4, x to the power of 4, x to the power of 4, yes? And then x. But this x, and that x will go out, yes? So what happens is x to the power of 3, the fourth root of x. I would prefer to stop here, but if you stop here, that's okay. Yes? Okay, by the way, let me test your understanding. I told you that, what is the fourth root of x4? What is this? No. No. I told you several times, I don't know, I'm repeating it all the time. It's absolute value of x. There is no way, there is no exceptions in mathematics. If you have even power, you have to write absolute value. But why didn't I write absolute value?
Because you have
So be careful. This fourth root, even, so let me write. 2n means even. X to the power of 2n even. If you write this x, it is not in general correct. You have to write absolute value. And this is always, without exception. But why I didn't use absolute value here, can you tell me? Yes?
Because it's multiplied by a variable with all exponents.
No, because this becomes absolute value in general, absolute value, and then fourth root of x. Then this becomes absolute value of x cubed. In principle, I should write like this. But I told you that I don't need to write this because I told you that the function, the derivative makes sense if I choose x from the domain. Yes? Go back and look here. Can x be negative? If x is negative, to the power of 5 remains negative, and the fourth root of a negative number doesn't make sense. So I told you that the derivative only makes sense if x is chosen from the domain. So it means that x is automatically positive. And this is why I don't need absolute value. Absolute value of a positive number is equal to the x itself, yes? Is that clear? Okay, that's the reason. Okay, now, when the lesson ends, do you know? At 10, okay. Okay, but let me change the problem slightly, then we will be in trouble. Yes? So I want you to fix that trouble for me, okay? So what do I do? Do you know how to differentiate this? Do you know how to differentiate this function? Yes or no? Yes? Okay, but now I multiply it by 5. Do you know how to differentiate this function? Yes? So you see, if I ask you, can you differentiate this? You would say yes. The answer is 3x squared. But let me just simply change it a little bit by multiplying by a constant 5. Okay, you know it from Math 3C, but there is no reason why it works like that. What is the answer to this? You know it from Math 3C. What is that?
52.
15x squared. So what you are doing, you are not caring about what I'm multiplying.
No.
You are doing your own job, yes? So you are saying that I keep 5, whatever it is, I differentiate this part, it becomes 3x squared, and then I multiply them, it becomes 15. This is the process, by the way. You have to think. If you are not thinking in that way, that's not the correct way of thinking. It's very extremely important for this course to think about the process of differentiation. But who tells you that this is valid? No, I want you to understand, because our goal is to categorize our functions. So I learned about that function. What I am doing, I am just multiplying by constant. From your previous studies, you know that you don't need to care about this. You do your job for this one and then multiply that constant by that one. But why? This is extremely important. I want to write here generic rules. So differentiation, extremely important. General rules. Okay? I will say what do I mean by general. So the first thing is that if you have a function, you multiply it by a constant, and if you want to differentiate it, then it turns out to be true that you just differentiate the function and multiply it by constant c. Yes? But it is not obvious. We want to prove that. Okay? The second question is that I give you this function. Do you know how to differentiate x to the 3? Yes. Do you know how to differentiate x squared? Yes. Now instead I add them. So what is the derivative? Probably you know from Math 3C. The answer is don't care about these things. Differentiate this one and differentiate this one and add them. But that is the second general rule. So if you have a function plus another function and you are interested to differentiate the whole sum, you don't need to be worried. You just differentiate the first one, you differentiate the second one, and you add them. Yes? And it doesn't matter if you have subtraction between them. Yes? Do you remember from Math 3C? If this is negative sign, then again it becomes 3x squared minus 2x. So the formula is true even for subtraction. By the way, let me emphasize here, what the formula tells you that it doesn't matter if you add and then differentiate, or if you differentiate first and then add. The result is the same. That is extremely important to interpret it in this way.
Wow.
And then the point is that I want to tell you that what happens for this one. For example, I don't know. So do you remember what is the derivative of x? You know. Let us assume that you remember something from Math 3C. Do you remember the derivative of this function? What is the derivative? The derivative. This is the only function, and so up to constant. This is the only function whose derivative is equal to itself. So the derivative of e to the power of x is equal to itself. But now the question is this. If I multiply this simple function by that simple function, and if I ask you, do you know the derivative? The answer is no. This is what you learned this year. So if you multiply two functions, let me write and cross it over. So might be these formulas are giving you this impression that if I have f times g prime, you might think that I can differentiate this, and multiply. Please write it down and cross it over. That is wrong. And that is what we will learn this year. This is not what you have learned in the... So you are not able to differentiate this very simple function, even though you know the derivative of this is 1, the derivative of this is e to the power of x. Yes? We will learn that. The formula becomes a little bit more complicated. It becomes the derivative of the first one multiplied by the second function itself, plus the first function itself multiplied by the derivative of the second function. So it becomes more complicated than this combination. And the same thing is for this one. Don't write it and cross it over. Okay? So these two formulas are not valid. In one of the sections in the book, we talked about this, which is called the product rule. And in another section, we've learned about this, which is called the quotient rule. Yes? We will learn about these two later. But these three in the book, they even don't bother to talk about. But this is necessary. It is important to realize that we have to do that. Okay, this one is simple, but let me just show this one for you once. At least you get a good feeling that these are not trivial. You see, this was probably a little bit trivial for you because you have used them so many times that you get used to it, yes? But if you want to follow the same feeling, you might get this formula which is wrong, yes? How can I prove this? For example, let us talk about the second. Oops. That will be enough for this today. So if I want to prove this formula, what do? I would say that let me call it ux becomes equal to f of x plus g of x. Okay? My goal is to show that u prime of x is equal to f prime of x plus g prime of x. This is my question mark. So I want to show that if I have the sum of two functions and I want to differentiate, I don't need to be worried. I just differentiate them separately. Yes? Why is that? I want to differentiate u prime of x. The formula is one single formula, and that is u of x plus h minus u of x divided by h goes to 0. Yes? That is the definition of the derivative. So I want to find the derivative of this function. Okay, can you help me to solve this one? So so the copy-paste parts are these parts, yes? What is u of x? U of x is this one. Yes? Okay, now can you help me to write something for this? What should I write for that? Yes? Yes, exactly. So I have to replace x with x plus h everywhere, yes? So this becomes f of x plus h plus g of x plus h, yes? And now I think you understand what is going on, because I can multiply this negative sign in, this becomes negative, this becomes negative. I will take minus f of x and write it next to this one. Yes? And then plus, I will take this one and write it next to this one. Yes? And I am supposed to divide it by h, but I can divide this one and this one separately. Yes? Is that understandable?
Yeah.
But now if I ask you, is this combination familiar to you?
Yes.
When limit, what is the answer to the limit of the first part? F prime of x. And what is the limit of the second one? G prime of x, because the function is g. So this becomes f prime of x plus g prime of x. Yes? So this is the reason, if I don't know, for some reason they talk about this from Math 3C, but they never talk about this, they use it. But that is not trivial, yes? So from now on you are allowed to use them, okay? But you know why. Proving this one is simple, proving that one is even simpler. So you see, this is the reason that we want to work. But let us keep these two, and we are not allowed to use them unless we learn how to do them properly later. Okay? Any questions? So the next lesson will be to complete this table a little bit more. And what you learn in Math 4, you didn't learn about sine, cosine, tangent, and you didn't learn about logarithmic functions. So this is what we want to add here. And then some functions you will learn how to add in the university. So this table will continue, yes? Thank you very much.